Hey Hawks, we are going to be looking at, can a compound exist in all three states of matter at the same time? So this lesson's going to give you that answer. Okay. Changing melting points and boiling points. So we've learned so far that materials have the property of a melting point and a boiling point, but you can actually change those melting points and boiling points. And that's done by changing the pressure. Okay, so the first thing you need to understand is what is standard pressure and temperature. We call it STP. And so basically it's a set of conditions that are used for comparing the properties of boiling and melting points. Okay, standard pressure happens at sea level. So what that means is it's either at 101.3 kilopascals or it's 1 atmosphere. In chemistry, we tend to use atmospheres more than pascals. So you could say that standard pressure is 1 atmosphere. Okay. Standard temperature is 0 degrees Celsius. Okay. Always. Doesn't matter if you're at sea level or not, it's 0 degrees Celsius. Okay. For each material, there exists a normal melting point and a normal boiling point. Those two happen at the standard temperature and pressure. Okay, so this is called a phase diagram. And this one happens to be for water. Every material has a different phase diagram. And basically the phase diagram will show you where is the substance a solid, where is it a liquid, where is it a gas, and then along these lines, so along this line would be your melting point, right? And along this line would be your boiling point. And along this line would be your sublimation point. And sublimation is where you're going from a solid straight to a gas, or you're going from a gas straight to a solid. So if you think of dry ice, you know how dry ice kind of smokes? That is sublimation. It's going straight from the solid form of CO2 to a gas. Okay, there's no liquid in between. Okay, so when we're talking about your normal melting point and your normal boiling point, remember that happens at 1 atmosphere. Okay, so looking at the side of your graph, it says this is pressure, so 1 atmosphere. I follow that line across until I get to the line between solids and liquids. That line is the melting point, and so at that point, we see that it's 0 degrees. If I keep following that line across at 1 atmosphere, I hit the next one, which is our boiling point. And if we follow that down to the temperature, it's 100 degrees. So our normal melting point and our normal boiling point would be 100 degrees for the boiling point and 0 degrees for the normal point, the melting point, sorry. Okay. But since the pressure and temperature can be changed, the melting and boiling point can be changed. So what we can do is if we want our boiling point to be at a lower temperature, we can just change the pressure, right? So if we wanted water to melt at a lower temperature, we could just increase the pressure, the atmospheric pressure, and then the melting point would change. Okay. Same with the boiling point. If we increased the pressure, then the boiling point would increase, the temperature would increase, right? The temperature needed for a boiling point. If we wanted that boiling point to be smaller, let's say we want that water to boil quicker, like when it's not it doesn't have to be as hot. Well, if we change the pressure, we could actually pull it down into, the 50 degrees Celsius, but then, the pressure has to be below 1 atmosphere. Okay. Now, when we're looking at this, you can see that all of these lines come together at this one point. Okay. That is called the triple point. And at that one point, all three states of matter exist at the same time. So if you were looking at water at 0.0060 atmospheres and at 0.01 degrees, right? So it's really close to zero. You would see that it was a solid and a liquid and a steam all at the same time. Okay, you could see that kind of like what we did in the very beginning. Okay, so when the pressure and temperature are just right, all three phases happen at the same time. This is called the triple point. Okay, so we can use these phase diagrams to figure out different temperatures and different pressures for materials. So this phase diagram for water shows the triple point occurs when the pressure is at 0.006 atmospheres and 0.01 degrees Celsius. So pretty much close to zero. Okay. Okay. So if we're looking at this graph, again, this is pressure and this is temperature. If you're given a graph that has nothing in it, there's no words, no letters, no, feel free to put your own stuff in, your own words. So this area is always solid. This area is always liquid. This area is always gas. Okay. And so it says refer to the phase diagram below. It's actually to the side when answering the questions on this worksheet. Okay. What is the normal freezing point of this substance? Now remember, normal is at ATP, average temperature and pressure. So 1 atmosphere. So if we follow this over, this line represents melting. And if we follow it down, we would get that our melting point would be 100 degrees Celsius. Okay. What is the normal boiling point? So again, 1 atmosphere, follow it over, and I would get approximately 400 Celsius, 400 degrees Celsius. What is the triple point of this substance? So the triple point, remember, is where all of these converge, all of these lines converge, right? So it'd be right at that point. And so if I follow that point over, the pressure is 0.75 and the temperature is just below 100. I'm going to say 90. I'm estimating. So you could have said 100 and that probably would have been fine. But it's just below 100. So I could say it's somewhere between 75 and 100. So I'm going to pick 90. Okay. Okay. So this is very similar to what you're going to do on your practice. All right.